Hello, everyone. Hope you guys are having an awesome Thursday. Um, for today, what we're going to be doing is a little walk around project. Okay, we're going to be walking around answering some of the questions from the notes. I didn't create any new problems, just as a review. All right, we're just reviewing relative velocity for our test tomorrow, which is over relative velocity and vectors. Okay, so what I'm going to do today is I'm going to walk through each problem. Okay, that's left on the notes, or most of them at least. I think I'm just going to leave probably the last two out, as long as you understand what's going on. All right, so if you need to pause the video at any time, that is fine. I'm going to walk through these, and if you have any questions, just feel free to ask. Okay. Okay, so here's question number one. It says vector A is 3x plus 5y and vector B is negative 3x plus 6y. Find vector C in the vector notation such that 2a, so 2a, which a is 3x plus 5y, plus 7b, where b is negative 3x plus 6y, plus 4c, which we don't know, is equal to 0. Okay, so there we go. So what I'm actually going to do is I'm going to line them up. So line them up vertically. So I got 2a. So I'm going to have 6x plus a 10y. Okay. Then over here I have a negative 21x plus 42y. Okay. So C, I know it's going to be 4. Well, first I want to solve what C is going to be. I want to find out what my x is going to be and what my y is going to be so that both equal 0. Okay, let's see. So 6 minus 21 is negative 15, so this is going to be a positive 15x. And that's going to be a positive 52, so that's going to be a negative 52y. Okay, now it is 4c. So what I actually got to do is divide these answers by 4. Okay, and when you divide your answers for 4, your C is going to be equal to 3.75x minus 13y. And that's your final answer. Okay, so this question has 4 parts to it. A plane travels with a velocity of 80 miles per hour north. Okay, so a plane, I'm going to write that out. It travels north at a velocity of 80 miles per hour.
Mr. Johnson, please call for 0.
Okay, north. Determine the velocity of the plane if the plane relative to the ground if it encounters wind at 10 miles per hour north. Okay, well, if I got 10 miles per hour boosting me along, how fast is the plane actually moving? For A, it'll be 90 miles per hour. For B, if I'm moving north at 80 miles per hour, and I have wind pushing me back 10 miles per hour south, my overall velocity will be 70 miles per hour. Now C and D get a little bit more trickier. Okay, so for C, once again, okay, I am traveling 80 miles per hour north. Okay, I'm going to zoom in a little bit. It's kind of hard to read. 80 miles per hour north, and then it says 10 miles per hour west. 10 miles per hour west. Okay. So I'm supposed to see how fast I'm traveling. Okay. Determine the velocity of the plane relative to the ground. Okay, so what is my velocity? All right, so here I'm going to actually have to find my x and my theta. Okay, so what is this angle? And what is my hypotenuse? So you can just do a squared plus b squared equals c squared in your calculator. A squared plus b squared. So I have 2 sig figs. Take the square root of that. So 81. Okay, so I have 81 miles per hour at what angle? So theta. So to find, I'm going to do the inverse tangent of the opposite over the adjacent. So 1 sig fig. 1 sig fig is going to be 7 degrees. So 7 degrees west of north. Okay. And D is going to be very similar. So D, so let me circle all my answers. D, once again, I'm going 80 miles per hour. Now this way, I'm going 60 miles per hour. What's my resultant vector going to be? A squared plus b squared equals c squared. So 60 squared plus 80 squared. It's going to be a big number, 1 sig fig. Okay. Take the square root. Oh, that's easy. 100. So it's 100. Oh, can't see that. I am so sorry. 100 miles per hour at, so the inverse tangent of the opposite over the adjacent. Okay. Inverse tangent of 60 over 80, 1 sig fig. 1 sig fig is going to be 40 degrees. And that's going to be east of north. Okay. Not too bad. All right. Going to move on to the next question. Okay, so this problem is very similar to the last problem we just answered, right? Okay, so the plane is flying 250 meters per second east. Okay, and then it has air, the air is moving 35 meters per second north. Okay, so first I got to find my hypotenuse. A squared plus b squared equals c squared. So it's going to be 2 sig figs. So I'm going to have 250. Wow. Sig figs. Crazy. At the inverse tangent of the opposite over adjacent. Okay, once again, 2 sig figs. 8.0. So I'm going to have 8.0 degrees north of east. Okay, for this next part, there are 3 questions, okay? So a boat is traveling across a river at a speed of 4 meters per second. So this is my boat traveling at 4 meters per second north. It encounters a river which is flowing east at 2 meters per second. If the river is 120 meters across, what is the boat's velocity with the current? Okay, so I am traveling, so A says I'm traveling north at 4 meters per second. And then the current is taking me 2 meters per second. Okay, what is my hypotenuse going to be? A squared plus B squared equals C squared. All right, I need 1 sig fig, 4 meters per second. I got to find theta, so the inverse tangent of the opposite over the adjacent. Hopefully you guys are starting to get in a routine. So 1 sig fig at 30 degrees, let's see, east of north. Okay, so there's A. B, for B, what I'm going to do is I'm going to zoom out so we can see everything real quick. So I'm going to take my actual angle here. So the boat's traveling with the angle of 26 degrees, 26.6 exactly. And if I know that this is 120, I should be able to find this number. So my hypotenuse. So if I do SOHCAHTOA, I'm going to take the cosine of 26.6 is equal to the adjacent over the hypotenuse. All right. And if you plug this in, you're going to get the hypotenuse to be 134.17. 134.17. Okay. From there, if you know that you are traveling at 4 meters per second, so your speed is equal to your distance over your time. So you're going to have 4 meters per second is equal to your distance, which is 134.17 over time. When you solve for time, one sig fig, I'm going to get 30 seconds. Okay. And that's your answer. Okay. So C talks about how far downstream you're going to go. Well, downstream, the only thing that's pushing you is the current. So downstream, your velocity is 2 meters per second downstream. All right. And we just discovered our time is 30 seconds. So velocity is equal to displacement over time. Okay. So 2 is equal to displacement over 30. So your delta x is equal to 60.